For us to graph each of the following functions, state the equations of the asymptotes. So first function here is a rational function. I'm just going to sketch these. They're not going to be perfect, but really I'm looking for what is the general shape and what are the asymptotes. So in this one, I cannot cross x equals 0, so that's my first asymptote because that would make the denominator 0. And then I have a stretch value of 10, but then I'm not adding or subtracting anything here. So my y value is also going to be equal to 0 for my asymptote. So it's positive, which means I'm going to have a graph that kind of looks like this. It's stretched out for sure, but in general, those are my asymptotes, and that's the general look of that equation. For b here, this is actually an exponential function. A couple things I know about exponential functions is that when x is 0, then this just becomes 1. So we'll call that 1 there. When x is 1, it becomes 0.5. So I know that this general shape is going to go like this. And the thing about exponential functions is that no matter how large x gets, I'm going to keep multiplying by 1/2 over and over and over again. And that's going to get really, 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 really small, but it's never going to cross 0. So that's what's going to tell me that I have a horizontal asymptote at y equals 0, because it'll never cross 0 no matter how big x gets. For c here, y equals 1 over x plus 2. Well, that one is also a rational function here, but I know that x cannot be negative 2 because that would give me a denominator of 0. I'm still going to have that horizontal asymptote at y equals 0 because I'm not adding anything at the end. And so, again, a rational function going to look kind of like this. And then last but not least, I have another exponential function here. So when x is 0, this becomes 1 minus 3, which is negative 2. And then if I were to plug in 1 here, it'd be 2 minus 3, which is negative 1. So I'm actually going to have it increasing kind of like this. The thing about this one, though, is that no matter how small I make x, if I plug in really negative numbers, it's going to make this some positive fraction. So it's going to subtract 3, and it's going to get really close to negative 3, but never cross it. So I'm really going to have my horizontal asymptote here at y equals negative 3 as my horizontal asymptote. So exponential functions are a little bit different. They do have horizontal asymptotes, but we got to figure out kind of where those are at. It's very similar to rational functions in the sense that it's really defined by this k value or whatever is added on the end here. So if you notice for these ones with the black boxes where there's nothing in them, I had horizontal asymptotes at 0. Whereas when I subtracted 3 to this last one, that's what gave me the horizontal asymptote at negative 3.